Hello everybody, Hassan here, engineer, MBA, and investor. And in today's video, I want to talk about how to extend the shelf life of certain foods. And of course, this is based on this research paper that was published just in late May. And I told myself, you know what, I think it's a good idea to cover this article to remind our viewers that although human therapeutics are probably the most critical thing right now when it comes to CRISPR, people are most concerned about, focused on for many reasons, commercial reasons being probably the top one. Agriculture, vegetation, everything about food, I've always thought that this was an untapped potential. I think people are not really talking about it more. You know, whether or not it's because the focus is more on human therapeutics or because people just don't realize it. I don't really, I'm not really going to comment on that specifically. I mean, I'm not going to make you choose between what is more important, human life or food life. I mean, I'm not going to go that route of discussion, but I will say that extending the shelf life of food is actually going to help save lives, human lives. And of course, this article here, let's go straight into it. So this was in Japan here, university in Japan. I'm not even going to pronounce it. I'm going to butcher it. So extending the fruit shelf life reduces food loss, therefore expected to contribute to food security. So just think about it, guys, when you go to grocery stores, your local grocery chain, or your mom and pop's store. How many times have you seen fruits, vegetables, legumes? They're basically done, right? They're done. They're not good quality. How many of them do you think are being thrown in garbage bins or being recycled, organic bins? It doesn't matter, right? What is the percentage of that? I mean, I don't think this article really talks about that, but I'm willing to bet that it's well above 5%. Okay, and that's a lot. That's a lot because you're talking about millions and billions of vegetables and legumes and fruits, that you could be feeding people, not just in, less developed nations in the world, but even in developed nations in the world. You pay, the banana for a pound or whatever. I think it's by pound, maybe less than a pound. No, I think it's by pound here in Toronto. I think I got a special deal, like 59 cents a pound or something. I'd be willing to bet you if you had this technology that increases food shelf for those bananas would probably cost now 40 cents as opposed to 59 cents. And therefore you can reduce inflation just by doing something like that, right? And of course it's easier said than done. But it starts with CRISPR Cas9, right? Which is what this article talks about. So it looks like they're editing out the specific gene here. Let's take a look. So they're talking about the Japanese luxury melon. Let's call it Japanese melon. They're talking about so it showed that the melon genome had 5 CMACOs, and the gene CMACO1 predominantly expressed in harvest fruits. Okay, so CMACO1 was expected to be a key gene for shelf life in melon based on this information. Okay, so they targeted that specific gene, and the final product of this melon did not have exogenous genes. The mutation was inherited for at least 2 generations, so they actually played this out. Or after editing out, they looked at the future generation of that fruit. Okay. So after 14 days of harvest was as follows. They look at the future generations, of course, was the ethylene production was reduced by 1/10 of that wild type. Okay, so early fermentation of the fresh fruits was observed in the wild type fruit, but not mutant. The results showed that CMACO1 knockout via CRISPR-Cas9 extended the melon shelf life. Moreover, our results showed that genome editing technology would reduce food loss and contribute to food security. So just one more thing I want to say before I start rambling on here. I want to see here, they said ethylene production. Okay, and ethylene production, do they actually define ethylene? Oh yeah, so they talk about here in this, it was actually in the second line that I missed. ACO, which is this long word here, is the final step of ethylene production pathway. This suppression via antisense technology has been demonstrated to extend shelf life of melon, apple, and papaya. So this is not just for melon. This is for apples, papaya, and I'm willing to bet there's other fruits in there. Family of fruits under the melon, under the apple. Apple is big, right? Just apple. It's just a huge fruit that if you could extend the shelf life, that would be amazing. So of course this editing goes specific hand to hand with plant breeding, right? So it's not like they're doing the edit and now they're just looking at the shelf life of that specific fruit. They're looking at the future generation. In this case, it was T2 generation, so at least two generations. So maybe they looked at third, fourth. I'm not gonna go all the way till the research paper here. I can link that in the video below here. Let you guys look at it, but it's really clear from their introduction and their conclusion here in the introduction that they were able to demonstrate the increased shelf life of just this Japanese melon. Of course, they claim that this gene that they modified is also present in apple, papayas, and they believe that this could have ripple effect across other fruits and subfamilies of fruits. And they go through the specific details here with the T1, T2 melons. Okay. I like this, guys. I like this. I've always said this many times. I think vegetation, when it comes to CRISPR, is the space that's least discussed about for many reasons. But I think this is something that we're going to be seeing a lot more. There's already genome edited foods as we speak. I think in Florida or in UK. I forgot which region between these two, or maybe both of them. There's already out there. It's already being out. Tomatoes, I believe it was, rice as well. So people are already looking into this. This is already a thing. But increasing the food shelf life, I don't think we ever made a video specific to that. And this research paper shows that, right? And I think this is something that we all have to take it seriously, right? Because let's be honest, there's lots of people that are malnutrition around the world, right? And I'm not, again, it's very serious to Africa and those regions, less developed regions in Pakistan and India. There's lots of millions of people that are not nutritious, like they don't have the proper nutrition there. So this would greatly help them. But I'm even talking about places like Canada and US. Think about all the food banks and think about what this impact could have to society if you had more food on shelves, longer on the shelves, and ultimately cheaper long term, right? If you increase the supply, right, price has to go down. Like this is just basic econ 101, right? You increase the supply, demand, of course, stays similar or if not more, but it can't match up with that increased supply because now we're talking about a whole different way of doing agriculture. And people would argue that agriculture, the idea of agriculture was the reason why we're here today in 2023. Humans are here, right? All the inventions that we've done. But what if we take that thing, agriculture, we put it to the next level? What is that impact in society, right? You got to think it through these lens, right? And I think these research papers, try to find these research papers and I try to talk about these, give more exposure in this channel. So hopefully you guys appreciate that. I'll link this paper in the description here. Let me know, guys, what do you guys think about this research paper? What do you guys think about agriculture, CRISPR-Cas9, increasing food shelf life? Let me know. I'll see you guys in the next video. Have a beautiful Saturday. I'll see you guys. Thank you.